In this video I'm going to show you how to find the equation of an ellipse when you know the coordinates of the foci and you know the distance from the points. So on the diagram that you can see here, I've marked the foci as F1 and F2, and the distance would be the distance from one foci to any point on the ellipse and back to the other foci. And that's because one of the definitions of an ellipse is all the points which are the same total distance away from two centres or two foci. So here's an example for us. I've given you the foci as -4 and 4, and the total distance from one foci to the ellipse and back to the other one is 10. The first thing we're going to do is work out where it cuts the x-axis so that we can have the value of A. Now let's imagine we're travelling from F1 all the way through F2, which is so far a total distance of 8, and then we go to the ellipse and back again. Now we've used 8 already, we had 10 in total, so that meant we had 2 left. And that 2 went from the point F2 to the ellipse and back, so we must have went out an extra distance of 1. So that means it must cross the x-axis at 5, which tells us that A equals 5. Now we want to find B. Now remember, that distance of 10 is to any point on the ellipse. So what we're going to do is move that point so that it's on the y-axis. Now we know the total distance is 5, we've got a similar triangle, so that means, sorry, it's 10, and we've got a similar triangle, so that means one side is going to be 5. Now F2 was at the point 4, 0, so we know the bottom side of that triangle is 4. Now using Pythagoras' theorem, we can say that b squared plus 16 is 25. So that means b squared equals 9 and b equals 3. Now we know A and B, we can put them into our equation of an ellipse. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Stay in infield with Winfield.